Watching this tutorial video or gaining experience with the simulator does not qualify a person to fly a real aircraft. The Boeing 737NG simulator, a basic tutorial. The flight simulator exhibited at the House of Future is an exact replica of the cockpit in the very popular Boeing 737 new generation aircraft, flown by many airlines around the world. The Boeing 737NG is a twin-engine airliner capable of carrying up to 180 passengers over a distance of thousands of miles. This flight simulator doesn't move, so you can't feel the G-forces affecting the airplane, but other than that, the experience is very close to reality because all the instruments and systems of the simulator work the same way and can be found exactly in the same place as in the real aircraft. Visitors flying the simulator can practice the same tasks as the one performed by real pilots day after day. You can even fly the simulator visually by looking out of the cockpit window because, thanks to a projection system and a database covering the entire globe, you always get a realistic view of the scenery with mountains, lakes, towns, and tens of thousands of airports, visibility permitting. The pilots. Modern airliners are flown by two pilots, mainly to make sure that there is always a pilot on board should the other crew member become incapacitated. But another very important reason for this is that two people cooperating with and supervising each other can work much more efficiently than a single person having to perform all the tasks by themselves. Usually you'll find the captain sitting in the left seat, with the first officer or the student pilot on the right. The precisely laid out procedures of operating the aircraft assigns well thought out roles to the two pilots, one of whom keeps flying the plane while the other pilot helps out by operating switches and instruments and handling radio communication with air traffic controllers. To eliminate errors, the two pilots continually supervise each other. This is achieved by using checklists. Checklists remind the crew of important tasks needed to be carried out in various phases of the flight. Checking is done by the assisting pilot reading out the items while the flying pilot checks and confirms the required status of instruments and switches.
Engine bleeds on. Packs auto. Landing gear up and off. Flaps up, no lights. After takeoff, checklist complete.
The cockpit. The switches and gauges in the simulator look exactly the same and are located in the same places as in the real aircraft. Altogether, over 100 instruments and yet another 100 switches. This may seem daunting, but of course you don't need to know every knob and gauge to be able to fly the simulator. Let's take a closer look at what's in the cockpit from top to bottom. Overhead, the big flat panel on the ceiling is used for monitoring and controlling aircraft systems. Seemingly placed at random, the switches and gauges actually belong to different subsystems. Standby control system, navigation, fuel, electrical system, anti-icing, cabin pressurization and air conditioning, lights. Amber warning lights indicate inoperative or faulty systems. In front of the pilots, on the top protruding part of the instrument panel, you'll find the controls for the autopilot. This is where you can set the desired heading, speed, and altitude. The autopilot in the simulator works exactly the same way as in the real aircraft, so Except for takeoff, it can perform all maneuvers automatically, including the approach and landing. Cockpits in old airliners look like a watchmaker's shop. There were so many dials and instruments scattered all over the place. Today's modern aircraft have electronic displays, and analog gauges are usually used only as safety backup instruments. The 737 has 6 displays on the main instrument panel. 4 of them, 2 for each pilot, show important data required for flying and navigation. You will spend most of your time watching these displays. In the middle of the main instrument panel, you'll find the standby instruments, a display showing the current status of the engines and other aircraft systems, and a lever for extending and retracting the landing gear. The instrument panel extends backwards between the 2 pilots. The 6th large display, which also indicates the status of various aircraft systems, is immediately below the main panel. On both sides of this display, next to each pilot, you'll find the flight management computers. The aircraft's autopilot can fly any route entered into these computers. The double lever between the seats is called the thrust levers and is used for setting engine power. Here you can also find the levers for operating the spoilers, the flaps, and the parking brakes. Aft of the throttle quadrant, extending behind the pilot's seats, there's a big rectangular panel for communications and navigation. This is where you can set the radio frequencies. Flying the aircraft. The main control device is the yoke. Turning the yoke to the left or to the right operates the control surfaces on the wings, thus banking the plane in either direction to make a turn. You may find this similar to driving a car, but there's an important difference. In a car, if you want to keep turning, you have to hold the steering wheel turned in that direction. In an airplane, you need to move the yoke only to initiate a turn. Once banked, the aircraft will keep turning. Pushing forward or pulling back the yoke operates the horizontal control surfaces on the tail. This raises or lowers the nose of the airplane. If you want to go up, pull the yoke. If you want to go down, push it forward. Again, you usually don't have to keep pulling the yoke all the way back to maintain a continuous climb. It's very important to avoid sudden control movements. Flying a plane requires continuous and minor control inputs. The foot pedals have a double function. They are brake pedals and steering pedals in one. To use them as controls, you should push in the lower part and move the pedals just like a teeter-totter. This way you can steer the nose gear on the ground and move the rudder, which is the vertical control surface on the tail. Use the pedals to keep the plane on the runway center line during takeoff and landing. The top of the pedals can be tilted backwards so they also move like car pedals. This is how you can brake the main wheels while taxiing on the ground. For normal braking, tilt both pedals at the same time. Instead of gas pedals, this aircraft has throttle levers for setting the power of the 2 engines mounted on the wings. Normally, both levers are moved at the same time to increase or decrease speed. On top of the throttle, you'll find 2 smaller levers. They are used for braking immediately after touchdown. When the levers are pulled up, the engines divert their exhaust hot air forward, efficiently slowing down the aircraft while it's rolling at high speed. The lever to the right of the throttles, and shaped like a wing, operates the flaps. You have to pull the lever up before it can be moved into another position. Flaps increase the surface area of the wings so that the airplane can take off and land at lower speed. In the middle of the main instrument panel, slightly off to the right, the lever shaped like a wheel is used to lower and retract the landing gear. First, you have to pull the lever out before changing its position. To retract the gear after takeoff, move the lever up. To lower the gear before landing, move it down. The 3 green lights above the lever indicate that all 3 wheels are extended. Primary instruments. Flying a new generation airliner no longer means having to watch dozens of different instruments at the same time. You can see all the important data required for a safe flight on a single display right in front of you, behind the yoke. The vertical tape on the left side of the primary flight display shows the speed of the aircraft in nautical miles per hour, or knots. On the right side of the display, there's another vertical tape, the altimeter, showing your altitude in feet. On the right of the display, you'll find another instrument, the vertical speed indicator. When the white needle is horizontal, the aircraft is holding its current altitude. When the needle is pointing up, the airplane is climbing. During descents, the needle points down. The largest instrument in the middle of the primary display is the artificial horizon, which shows you the attitude of the aircraft relative to the horizon. Brown means the ground, and blue symbolizes the sky. During turns, the artificial horizon tilts the same way as the real horizon, as seen out of the window. Shown with an arc at the bottom of the display is another very important piece of data, your heading. The small triangle represents the nose of the airplane, while the arc moves under the triangle as the aircraft turns. In aviation, directions are defined in degrees. 0 degree means north, 90 degrees is east, 180 degrees points to the south, and you're flying west if your heading is 270 degrees. The heading indicator below the artificial horizon indicates a value divided by 10. So 30 stands for 300 degrees, meaning northwest. The same applies to runway directions. At Ferihegy Airport in Budapest, for example, runway directions are indicated as 31 and 13, meaning 310 degrees and 130 degrees. Traffic pattern. A basic flying task in aviation is the so-called traffic pattern. This includes taking off, climbing out on runway heading, then executing 90-degree or right-angle turns. After the first turn, you start flying away from the runway direction. With the second 90-degree turn, you should fly opposite your takeoff direction until the runway is behind you. By executing the third right-angle turn, you should start approaching the airport. The goal is to make a final turn towards the airport in such a way that you can land on the runway without any major changes in your heading. Takeoff. Before takeoff, you should taxi slowly to the active runway. Push the throttles forward gently, then move them back to idle again. Remember, you can use the pedals both for turning and braking. Pushing in the bottom of either foot pedal steers the nose gear, and you can brake by tilting both pedals backwards at the same time. There are two important speeds for takeoff: the decision speed and the nose gear rotation speed. The decision speed, abbreviated as V1, is the speed beyond which you can't stop the airplane on the remaining runway. Passing the speed, you have no choice but to take off. The other key speed is VR. When reaching it, the assisting pilot calls out "rotate." This is when flying really starts. To take off, first you need to set the engines at high thrust. This can also be done by the autopilot so that you can concentrate on flying the aircraft. Just press either small button on the top of the thrust levers to switch on the automatic thrust, and takeoff power will be set automatically. While accelerating, keep the plane on the runway center line by steering with the pedals. When you reach the proper speed and hear "rotate," gently pull back on the yoke to raise the nose. The vertical speed indicator should start showing a climb, and the altitude starts increasing. At this point, you can retract the landing gear as they are no longer needed up in the air. It's very important that instead of enjoying the outside view, you should watch the display in front of you, where a computer system called the Flight Director helps you fly the aircraft. On the artificial horizon, two magenta lines will show you the required control movements. The horizontal and vertical lines should intersect at the small point in the middle. If, for example, the horizontal line moves upward from the middle, you should steer up by pulling back on the yoke. Similarly, when the vertical line starts wandering left of the center, you should increase bank to the left, which means turning the yoke a bit more to the left. To sum up, steer towards the lines and always keep them centered. After takeoff, you should retract the flaps as they are needed only for lower speeds. The rest is easy. Make sure you keep the two magenta lines in the center of the artificial horizon with gentle control movements. Approach. The most important thing while approaching the airport is to keep your proper descent rate and speed, and to avoid large heading changes. This requires a lot of practice, but the Flight Director system also comes in handy here, provided the airport is equipped with an Instrumental Landing System, or ILS. The ILS consists of radio transmitters placed near the runway. One of the radio beams shows the straight line leading to the runway, while the other radio transmitter helps pilots to stay on the glide slope and land on the runway. The aircraft's navigation system processes the ILS signals and shows the information on the pilot's primary flight displays. The magenta diamond at the bottom of the artificial horizon indicates your deviation from the imaginary straight line leading to the runway. If, for example, the runway extension line is to the left of the aircraft, the small diamond will move to the left as well. You should turn further to the left until the diamond moves back to the middle. Deviation from the ideal vertical path, called the glide slope, is indicated by another diamond moving on a vertical scale along the right side of the artificial horizon. If you are too low and the glide slope is above you, the small diamond will be upwards from the middle of the scale. All you have to do is watch the flight director, the horizontal and vertical magenta lines showing you the required control inputs, and always keep the bars centered. During approach, you need to extend the flaps gradually so that the airplane can stay airborne at a lower speed. And don't forget to lower the gear. Landing. When you spot the runway, choose a point on the first third of it and fly the aircraft there. Avoid sudden and large control movements. You should stay on the runway center line with small and gentle control inputs, and keep your descent during the entire approach. Flying over the runway, and only seconds before touchdown, you can use the rudder pedals to adjust your heading. Keep the wings level, pull the throttles back to idle, and raise the nose a little for a softer touchdown. After landing, the automatic braking system is activated, and the spoilers deploy on the wings. When all three wheels are on the ground, turn on the thrust reversers.
Hotel Alpha 364, runway 26 left vacated via Bravo 4.
The possibilities of this simulator don't end here. You can fly anywhere in the world, choosing from tens of thousands of airports. You can practice procedures real pilots do, and test your skills using selected or real weather conditions. Have a nice flight. Warning: the switches and controls in the simulator must be operated gently and carefully. If you want to fly the simulator, please register at the info wells.